All right, number one, we're evaluating the limit algebraically. So first step, always try direct substitution. So I'm going to substitute 2 in, and you don't necessarily have to show this work, but I will here. 3 times 2 squared minus 7 all over 2 plus 2. So we get 4 times 3 is 12 minus 7. We get 5 over 4. So here, direct substitution works. Now, in most cases, you're not going to be that lucky that it's going to be that easy. So if we look at number 2, direct substitution here, if we try putting 1 in, this time I'm not going to write it all out. 1 cubed is 1 times 3 is 3. Here we get 1 times 3. So we've got 3 minus 3. We get 0 on top. On the bottom, 1 squared plus 1 minus 2 gives us 0. So we have 0 over 0. If that happens, we're going to try one of those other techniques, and we'll find some other ones later. But for right now, we're going to see, should I factor this or multiply by the conjugate? There are no square roots here, so I'm going to go ahead and factor the top and the bottom. Now, when I do this, I'm going to keep the limit here. Limit as x approaches 1. Trust me, it's a good idea to keep that there because a lot of times students that don't write it forget the last part of the problem and don't finish the problem and get full credit. So it should be written there every step of the way. Limit as x approaches 1. On top, we can take out a 3x squared, and then we're left with x minus 1. On the bottom, we can factor this into 2 binomials. So we're going to have an x and an x, and our two numbers multiply to give us negative 2, add up to positive 1, so we get plus 2 minus 1. So we have factors on top and bottom that are the same. We can cancel that out. So we know this function is going to have a whole at x equals 1. It's going to look just like the function 3x squared over x plus 2, except for the whole. Those two functions are going to have the same limit. So what we can do is find the limit of this one, and it's going to be the same as the limit of that. So we have 3x squared over x plus 2. This x minus 1 that was on top and bottom, that's what was giving us the 0 over 0. Now that they're gone, we're not going to get 0 over 0 anymore. We're going to get our actual limit. So we can use direct substitution. Just put 1 in for x. So on top we get 3, bottom we get 3, so our limit comes out to be 1.